Hello students, we're talking about the functioning ecosystem. This we are talking about the functioning ecosystem. The functioning ecosystem that is functioning and exploited. And as we know, ecosystem has to do with the interaction or relationship between living organisms and what? Environment. Living organisms and what? And the environment. So here we'll be considering the role of autotrophs, heterotrophs, and decomposers in our environment, draw and explain the tropic levels, explain energy transformation, and give application of the what? Of the laws. Right now, start with what? The role of the before that, we know that the relationship at which feeding relationship is very much important in this because how the autotrophs provide food for the heterotrophs and also how the decomposers work on this to return it back to what? To the producer and the heterotrophs. And the thing goes like that in what? In circle. So since all living organisms must obey or must obtain or need or use what? Energy and nutrient from the environment in order to remain alive. What we need to use to sustain in life is what? Energy. There's a definition about energy as ability or capability to what? To do what? If you don't have energy in you, you cannot function. And the lesser the energy, the more the threat what? To life. So we need energy as living organisms to be able to what? To survive. So they also have the relationship. All these have the relationship how they feed from the producers to the what? To the consumers, and the consumers back to the what? To the producer. So this makes an ecosystem a functional unit. So all organisms fall into one of these three major groups or body components. Each are the what? The autotrophs, the heterotrophs, and the what? The decomposers. The heterotroph also called the what? The consumers. So the autotroph provide food for other organisms in the habitat. As in the terrestrial habitat, they include grasses, trees, and shrubs, while aquatic autotrophs include phytoplanktons, the seaweeds, and so on. The heterotrophs, which include the herbivores, that is the herbivorous animal that feeds on what? On plants. The carnivores, which feed on what? On what? On bones, meat, and like. Then the what? The omnivorous animal that feeds on what? On both plants what? And animals. They feed on both plants and what? Animals. So their feeding is secondary on what? On like the primary consumers, which are the what? The heterotrophs and the what? I mean primary consumers, which are also the heterotrophs, under which you can find the what? The herbivores and the what? And the carnivores. But the omnivores are somehow more advanced than the other two. So terrestrial heterotrophs include the cow, dog, the lion, man, and so on. While water leaves, the tadpoles, the larvae or insects are found in the water, they are called aquatic heterotrophs. So decomposers like termites, larvae, housefly, bacteria, fungi, all that break down dead what? Organic matter to release simple chemical compounds which can be absorbed and used again. When it's absorbed and what? Be used again. So when bacteria, like denitrifying bacteria, feeds on some other nitrogenous substance and deposited in the soil, the plant will use it again and it goes back following that particular one, that chain, moving from what? From the what? From the producer to the what? To the consumer. These are the what? Autotrophs. Then to the consumer and the heterotrophs. Then back to the what? To the decomposers. Decomposers. Then back to what? To the what? To the producers. So that's how the chart goes. Then after this, we are going to discuss about the trophic levels. Of all the three body groups I just mentioned, consumers have better chances of survival than any of these in the world in any given ecosystem. For instance, so we consider the trophic levels that are involved in the world in an ecosystem. So in an ecosystem, energy and nutrients are transferred step by step among organisms along a feeding pathway. There's a pattern, there's a line in which they follow in transferring what? The energy. So the feeding pathway in all ecosystems follow a simple pattern which is as follows. One, it begins with the producer. After the producer is extend the word primary consumer. Primary consumer, it goes to secondary consumer, then the secondary consumer, it goes back to the word the composers, and from the composers back to what? To the producer. That is just as simple as it is. So a movement from producers to the composer, there's disciplines of what? Energy. Energy are being what? Released. Energy are being released and used up in that process. So in that pattern we call it what? The tropic levels. Level of feeling. Call it tropic what? Levels. Or level of feeling. So and the first step, as I always explain, that is the step at which food are being made. The tropic levels is in each step along a food a feeding pathway explains how food and energy are what transferred from one of the levels to the other levels. So tropic level 1 consists of the procedure, as I said earlier, the autotrophs. Then tropic level 2 consists of the primary consumers. Then we have another level 2 is subdivided into the consumers, that are the carnivorous, and the parasitic organisms, the scavengers, and the final consumers eventually is the composer. So there's what we call food chain and food web. Food chain and food web is used to deeply explain this. And what is food chain? I will start with that. What is food chain? Food chain. Food chain is the feeding relationship involving the transfer of energy through food from producers to consumer in a linear form. It's on a straight line. It must be represented linearly. For example, I have a grass, zebra, and lion. As you all know that a lion will feed on the zebra, and the zebra also feed on the grass. I can represent my food chain for that as from grass to zebra, and zebra to lion. You can see there from grass to zebra, and zebra to lion. So the grass is the producer. This one is the consumer. Let's just consumer. We have the producer, the autotroph, then we have the heterotroph. Can call this one the consumer 1, consumer 2. Consumer 1, consumer 2. So autotrophs, heterotrophs, the heterotrophs, and the one that depends on the other one for you. So you can call this one the primary consumer and call this one secondary consumer. So another one I have, you can show one longer than this three. It can be like 4, 5 of it, but it will only show and explain more about the producer and consumer of different degrees. If you have like 4 or 5, where you can have more than one consumer, you can extend it to tertiary consumer. For example, you have grass and you have grasshopper. So even your grasshopper, you have toad and snake. You have toad and you have snake. You have toad and you have snake. And from that you can see what we have here. The grass is the primary producer, the primary consumer, secondary consumer, and tertiary consumer. The grass is primary producer, autotroph, primary consumer, secondary consumer, and tertiary consumer. So this can be given in any form, but just note that the producers comes first, then followed by the next one, the primary consumer, secondary consumer, and if probably you have the tertiary. So also, as it is on the terrestrial, we have it in in the aquatic environment too. For example, when you have Spirogyra, you have tadpoles, you have crab. You know that tadpole feed on Spirogyra, the crabs feed on tadpoles. So also you can present your producer for the Spirogyra, The tadpoles are the what? Are the what? Primary consumer. The crab is what? Secondary consumer. Sclerogyra. Have the tadpoles. Now the tadpoles. Then we have the crabs. Crabs. In an aquatic environment. So Sclerogyra are the producers. They are autotrophs too, because they make use of sunlight to what? To make their food through photosynthesis. Then this one, that goes primary consumers and secondary consumers. You go beyond that, you have the tertiary what? Tertiary consumers. So I can see what I just did on the board concerning the primary producer, primary consumer, and what? Secondary what? Consumer. So that is that about the aquatic environment. So therefore, in a food chain, food energy is transferred from one what? From one organism to another in a linear form. So most food chain begins with producers, but fewer of them start with dead plants or what? Or animals. So as you can see here, what I just explained now, some can even start with what the primary producer will need to grow. Yes, like when you have humus. Humus are the nutrients that is supplied to the plant from the soil or its environment, so that it can what? It can make it grow and grow well, so that it can produce what the carnivores or the heterotrophic heterotrophs will feed on. So now, leaving that, we now go to food web. Food web is a detailed diagram of what? Of feeding what? Relationship. I'll just try and define that before I go on. Food web. What is food web? Food web is a complex feeding relationship among organisms in the same environment with two or more interrelated food chain. You have two or more interrelated what? Food chain. As we had it earlier on, the food chain and earlier, but when you interpret it in a food web, they come in diverse form. Then the way it goes, you can easily bring it out and work it out and still extract the what? Your food chain from it. A food web therefore contains more organisms than that of food chain, as I've said. A simple plant will be fed upon by more than one or two organisms in an ecosystem. The consumer has a better chances of survival because it feeds on different types of plants or animals in a world, in a food web. So I'm going to give us a kind of diagram that shows the feeding relationship in a what? In a food web. Let me just quickly show that before I go on. You can see this. You can see this. This is a plant. The mouse will feed on the plant. And this mouse, rabbit will feed on it. Owl will feed on it. The wild cat will feed on it. So other things can feed on the mouse apart from one. So you can either produce a food chain from here. Can produce a food chain from here. This other can produce a food chain from here. This other can produce a food chain from here like this. So that means food chain. You have what makes up a food web is many words. They are comprised of many words. Food chain. So this plant producer, the mouse to the owl to slave, the snake to the what? To the bird. Then from the what? From the mouse to the white cat and the fed up by what? By lion. Then when the rabbit takes the mouse, you have the goat to what? To the rabbit. Then the white cat to the rabbit. Then the jackal goes straight to this. So the goat will feed on the what? On the plant. Then this goat will feed on affected by the what? By the lion. So you can see the relationship that goes on among what? This we call it what? A food web. That's a food web. So let's be able to learn and draw diagram and explain earlier about food levels and what? And the food web. So when you compare, the next is explain energy what? Transformation. How energy are being transformed? Energy are transformed using what? the flow of energy or ecological pyramids. We call it pyramids. So pyramids are diagrammatic pyramid are what? A diagrammatic representation used in ecology. They include pyramid of number, pyramid of energy, and pyramid of biomass. So taking the first one, pyramid of numbers. Pyramid of number. Pyramid of number. That one is referred to the numbers of individual organisms at each trophic levels, decreasing from the first to the last level in the food chain. As you know, the pyramid goes like this, just like this. So here, if I have this, I have this, I have this, I have this. Then this trophic level 1, 2, 3, 4, 5. So here I can have grasses here, and some be represented like this, and just like this, like this, like this, like this. It's still a pyramid. You can see it either like this or like this. So here, if I have grasses here, now this is, and I have grasshoppers here, grasshopper. And after the grasshopper, I have lizard. I have man. I have 1, 2, 3, 4. That is 4 levels, 4 trophic levels. I can take that 2 layers: grasshopper, grasses, grasshopper, a lizard, and I have man. I can use number. This one is 80. This one can be like 30. This one can be like 50. This one can be like 5. You can see that the number decreases from this one, decreases upward. That's what we call pyramid of what? Of number. So the decreasing what? The number of this upward. So we call pyramid of what? Of number. So call it decreasing number of what? Organisms. So then leaving that one, we go to pyramid of number has the following defects. The defect that is attached to this is 1. The individual organism is given the same status, though they vary greatly in size. Grass and trees. And see, this primary, the first one that I here, the primary producer, I only know grasses here. But other producers are still here. There may not be as much as what this 80 for grasses. That's what they mean. So in a particular land or forest, you may not have up to 80 grasses, but you can have like maybe 2,000 of what? Of spirogyras, or have 2,000 of autotrophs. There is more than this. It varies. So also grasshopper. In a particular forest, you can have 30 in the forest, and now you can have like 100, but it's still following the same way, the same trend. So the trees and grasses group together as producers and is not drawn to scale. It's just a representation, it's not drawn to scale. Then the next one we have here is pyramid of energy. This is the amount of energy presented in the what? In the living organism at different trophic levels of a given food chain, which decreases from the first to the last, from the base of the pyramid to the apex. So the energy you have here represented upward. Here they use number. You can make more of energy like 80 joules. Now see that following this, the energy decreases upward too. So the energy that is being consumed here won't be as this, but as it goes up, energy is being transformed, and being transformation, some are lost in the form of heat, some are lost in the form of heat energy. So that is it. The last one is what? Pyramid of what? Biomass. Pyramid of biomass. Pyramid of biomass. Pyramid of biomass refers to the size and number of living organisms, how much they are, their number. So it represents the total weight or dry weight of the organism in each trophic level. So this gives a more accurate picture of the relationship between organisms at various trophic levels in a food chain, and the pyramid of number that you have is more detailed than what? Pyramid of what? Of numbers. So then leaving that we go to the energy loss in an ecosystem. So energy is the ability to do what I said earlier, ability to do work. So all living organisms obtain energy from the food they eat. The food is produced by green plants or the autotrophs, and other organisms depends on them, either directly or what? Or indirectly. So as energy is passed from one organism to another along the food chain, it is progressively lost due to respiration, energy used for what? Various metabolic activities. And as it, in most ecosystems, only about 1 to 10% of the solar energy may be available to photosynthetic producers. So here, if the energy used in making food here is about 80 joules, it can't be more than, it must be less, because in transformation of that energy to this place, there is loss of energy. That's what the diagram is showing to us, and the way it goes. So this now helps us to identify how to illustrate this energy using the word loss of thermodynamics. Thermodynamics simply means heat change. Heat as a form of energy that is subjected to change in living organism is governed by two laws. The first is what? The first law of thermodynamics and second law of thermodynamics. I will state the first law. The first law of thermodynamics states that energy can neither be created nor destroyed, although it can be changed from one form to another during what? Chemical reaction. So examples: chemical energy in food is converted to kinetic energy and heat energy in our what? Muscles when we walk or run. The energy you gain for that particular food is being transformed to what you use up. So at the end, when you look at the energy that you are trying to explain at the cost of what? Showing what you have consumed, you will eventually lose some to the environment. Like when you eat food now and you are growing, the stress you are giving yourself tend to explain what it means by loss of energy. And due to that stress, someone can begin to sweat. In that sweat, heat is coming out from the system, energy is being lost to that. So that's what the law is trying to explain, because now at the point of transmission of energy from one form to another, some are being used in form of heat. But the energy can either be created or what? Not destroyed. So another one is second law of what? Thermodynamics, which states that in any conversion of energy from one form to another, there is always a decrease in the amount of useful energy. The useful energy is decreased. You eat, right? And at the end you are full. You need to, that food you have taken gave you energy to move about. In moving around, you need to lose some of the energy. Whether due to stress, due to the heat, due to the environment, due to yourself. So there's lose. So no transformation of energy from one state to another is ever 100% efficient. Never. Because it will be used up. Part of it will be used up. So during metabolic activities in the body, some chemical energy is constantly lost as heat energy from the body of an organism. As energy is converted from one form to another, there will always be what? Energy loss. So I just explain now the first law of thermodynamics and second law of what? Thermodynamics. So now the food chain and thermodynamics. In the first law, as I said earlier, in the food chain, that is the linear feeding pathway. Energy from the sun is transferred from the producer to the consumer, and the sum total of the energy remains constant. The plant, a green plant, needs sunlight with some other what constant like carbon dioxide, water, chlorophyll, so that can make food through the process called photosynthesis. So in doing that, and in sum of the total energy that you gain during those kind of combustions, it is always what? Constant. That is what the law is telling us. Then the second law now tells us that as energy is transformed from one tropic level to another, part of it is converted into heat, and being heat energy, it is lost to the environment among a progressive drop in energy in successive tropic level. So for each tropic level as you go up, energy is being what? Being lost to that. So pyramid of energy and loss of thermodynamics. In the first law, as I said earlier, the energy of the producer at the base of the pyramid is higher and is gradually transformed to another tropic what level. You can see it here. It's higher here, but it's at point of transformation, it reduces upward. So using the second law, as energy is what? Is transferred from one tropic level to another. What happens? Part of energy is converted to what? To heat, and it is lost to the what? Environment. So I'm going to show us a picture on this that will explain more about the change in the energy. Can see this diagram? At this level, you can see this here. You can see this. This is the grass, the primary producers. The green grass, you can see them here. It is bigger to this. But at the point of converting this one to this, what is released? Energy is transferred to this here. What is lost? In the form of heat, energy is lost in the form of heat. So for the primary consumers too, when they consume what they have here, they gain energy. The energy is what? Transformed again to the next one, to the secondary what? To the secondary consumer. And you can see secondary consumer there. This lake that we have here. And in doing that, when they take the energy and they are trying to convert it, what happens? They also lose energy in the form of heat too. Then to the next one, here is actually what? Consumer. You can see the pyramid there. Consumer out there. We call it pyramid of what? Energy. Pyramid of what? Energy. So you can see it from the producer upward to what? Primary consumer, then the secondary consumer, then the tertiary what? Consumer. So when this guy will come down to the floor, then their waste is being used to what? To develop what is needed or required for this one to grow, so that they can be what? This one can feed on this can feed on this, and in that order, energy is being what? The thing is like goes back from the producer to the what? To the consumer. So as I said earlier, this particular topic will help us so much understanding what we need to know about the pyramids of energy. So energy flow and loss of thermodynamics, as I said earlier. Using the first law, energy flows from producer to what? To the first primary consumer, to the second, that is secondary consumer, and to the what? The tertiary consumer in a what? In a food chain. The energy flow in a food chain is therefore in one direction. So using the second law, energy transfer between tropic levels is not 100%, as I said earlier. Successive levels have less useful energy and so can only support fewer organisms. Producers like green plants have the highest amount of energy. When herbivores feed on the plants, the energy level is reduced. And when carnivores consume the herbivores, what happens? The energy level is what? It's reduced. Let me bring a chart. You can see this, the movement of this. You can see a food chain here. You can see this food chain. The herbivores. You can see it. The carnivores, the omnivores, the decomposers. You can see here the grass producers gain the energy from the sun to produce what this one feeds on. The bird is the primary consumer. Then the chicken feed on the bird. Then what? Human being feed on the what? Chicken. Then the decomposer. You can see it here. You can see it up here. The grass producers, they get energy from the sun. They produce their green and fresh parts that this one will feed on. When the bird feed on it, the chicken follows, then human being follows, and when the human being dies, what happens? The dead is decomposed, then plants use upward. The decomposed part and make it what? To grow fresh again. And that's, you can see this linear. This is linear, this is a straight line. This is a food chain. A food chain. So in the time when it comes to fishing, while the herbivores, the producers, the autotrophs, then the carnivores, omnivores are the what? The heterotrophs. And the composers are the ones that feed on the either this or this. So from there we have a balance of fishing in the can. So food chain is the path by which energy passes from one living thing to another, especially from the what? From the autotrophs to what? To the heterotroph, to the composers, and back to the what? To the autotrophs. And you can see examples here that have to discuss more about the topic that we are doing. So in a functioning ecosystem, there must be a good interaction between the living organisms and what? And the environment.